So today we're going to do phase shifts of trig functions, and there are 4 rules for phase shifts. Phase shifts are really just horizontal shifts, left and right. That's all they are. The first rule is to, or the first step in the process is to change the scale. So we'll change scale by the period, the new period. So we learned that last time. That was worksheet 5. We learned how to change the scale. And the second step is to plot the center line and the new center point. So plot center line, and then I'll say slash center point. Now, when you plot the center line is really just a vertical shift. So we'll just say vertical shift. That's up. And then the center point is a shift left and right, so that's called the phase shift. So we haven't learned that yet, so that's what we're going to do now. 3, let's see. Okay, so you plot the center line, then you want to plot vertical asymptotes, and we'll say maybe dotted sines and cosines. All right, taking off the marsh. All right, have a good weekend, man. Okay. So plot vertical asymptotes and dotted sines and cosines, and then 4 is to plot the actual graph. So I'm going to say plot the parent function with shifts and stretches. Okay, so really the only new thing here is this part is the phase shift. We've really done everything else except that. We've been trying to go in layers here and learn one thing at a time. And so this is the icing on the cake, or the last step. It's really not that fun, but it's phase shifts. So let's, I figured what we would do is the odd problems here. That gives us a good mix of problems. So let's do number 1 first. Number 1 is a cosine graph, and we want the amplitude here. Sine and cosine are the only graphs with amplitude. All the others have no amplitude. So the amplitude is 1 for cosine here. It's just the coefficient of cosine. And then the period is determined by the coefficient of x. So the period is 2 pi over b for sine and cosine. And x in this case, the coefficient of x is just 1. So we get a period of 2 pi. The phase shift is this part here. That tells us the shift to the left and the right. Is this one to the left or to the right? Yeah, this one's the left. So we'll just say left pi over 4. And here this one has no vertical shift, so we'll just say none. Okay. So now let's flip the page to the next, or to the graph number 1. So we'll say cosine of, what was it, x plus pi over 4. Okay. And the period, we'll use a t again to represent the period. That's just 2 pi. And then we'll say ps for phase shift, and we want to the left. Pi over 4, not to the right, so that's left pi over 4. Let's go ahead and plot that. So what's the first thing is you want to change the scale according to the period. So the period, yeah, it's just the same that we had on our quiz. So 2 pi, pi over 2, and 3 pi over 2. That looks good. And let's see. The center line, that's number 2. That's the second thing that we should always do, is right here. And notice we're shifting to the left by pi over 4. Unfortunately, our tick marks only go by pi over 2. So what I'm going to do is come through here and split each one of my tick marks in half, so I know where the pi over 4 tick marks will be pi over 4 is half of pi over 2. And so the red X on my center line should be right here. That's to the left by pi over 4. Cosine always starts out 1 above the center line. So the first point that we want to put down is right here, 1 above the center line. And then it's 1 above the red X, or the X that we have there. And then for every multiple of pi over 2, we want to shift either up or down. So it's going to be in the middle of our hash marks. It's not going to be on the hash mark. So it's kind of a pain to graph this because it's not right on our standard hash marks, but you can still get the idea here. Now, usually I try not to give you problems like that where they're right in the middle of the hash mark because it's painful to grade, it's painful to look at, and it's easy to make a mistake. So I try not to give these, but sometimes we'll see. I think we have a couple examples like that. Problems in real life don't work out nice. So usually, like if you're shifting something, it's not going to shift a nice clean amount. It'll shift an ugly amount usually. So it's good to see problems like that, but it's not fun to do them by hand. Okay, let's try the next one. So number 3 here, secant 2x minus pi. Well, since it's secant, there is no amplitude. Only sine and cosine have amplitudes. The period is the formula 2 pi over b, and b in this case is the coefficient of x, which is 2. So that's going to be 2 pi over 2, or just pi. So the new period is just pi. Now, it looks like the phase shift is to the right by pi, but this is actually a compression of factor 2. So instead of shifting to the right by pi, the shift has been compressed as well. And in order to find that compression, what we have to do is factor out a 2. So if I factor out a 2, we want to pull a 2 out of that pi, so it's going to be pi over 2. It doesn't have a 2 to pull out, so it has to borrow 1 in the denominator. If you're worried that you've written this wrong, you can always distribute that 2 back through, and you get 2x minus pi, which is what we had originally, so you know that you factored it correctly. So this, right here, is our phase shift, so the negative pi over 2. So that's to the right by pi over 2. And this one still has no vertical shift, so we'll say none. All right, good deal. So let's go to number 3 on the next page. So this is going to be secant of 2x minus pi, I think is what it was. The period is pi, is what we calculated, and the phase shift is to the right by pi over 2. Good. Now remember, when the period has changed, you want to replace the old period. The old period was 2 pi. It used to go right here. We want to replace that with the new period. So the new period is pi. So we'll put that there, cut it in half, pi over 2, cut that in half, pi over 4, and then we can count 1 pi over 4, 2 pi over 4, and 3 pi over 4. So that gives me my scale. So this is 3 pi over 4. Okay. We're graphing secant, so we want to do a dotted line cosine graph. We should put in our center line and any shifts. We know that it shifts to the right pi over 2. So this red X, the center, the new center point, happens to be right on one of our hash marks, which is nice. It's nice when it works out that way. It's just easier to plot. So here, we want to graph a dotted cosine. Good. All right, so cosine starts out 1 above our center point. So we'll put a point right there. And then it goes down, so that's the peak. We want to go down back to the center line, and then we'll put points in the reverse order going the other direction. So this should be dotted. If you do a solid line, it's technically incorrect, so we want a dotted graph there. And just as before, the vertical asymptotes for secant and tangent should be on either side of this red X. So we'll put vertical asymptotes wherever the graph crosses the, so that's a crossing point. Uh-oh, did I get this wrong? I think I might have got this side wrong here. I don't know if you just copied that or if you got it right. There, that looks better. So there's where my vertical asymptote should fall, just like that. Good. Every peak gets a point and every valley gets a point, so we'll put points here, 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 and here. All the peaks go up to infinity and all the valleys go down. So just like this. Yeah, so that was a lot that we did there. We actually shifted the graph and we compressed it, so we're putting it all together here. Problem number 5, actually, I think is the first time we put everything together, even with a vertical shift in there. So let's go look at that one on the previous page. Yeah, so number 5 here is back to sine. This one has a vertical stretch of 3, so that means the amplitude, sine and cosine are the only ones with amplitude, is 3. And the period is going to be 2 pi over b, and the coefficient of x here is 2, so we want 2 pi over 2, or just pi, as our period. So that's the new period. And the phase shift, in order to calculate the phase shift, you have to factor out a 2. So we get 2 times x minus, just like the last problem here, we are going to get a pi over 2. So that's a shift to the right by pi over 2. So we'll say right pi over 2. And then we do have a vertical shift this time, so we'll just say up by 1. That's this 1 out here on the end. Okay, good. So let's plot that one on the next page. Yes, yes. So, yeah, whenever you're calculating that phase shift, you always have to pull that out. And the reason is if you try to treat that as the phase shift before you factor it out, then that's really a shift before the compression. So you have to take that compression into account first, and that's by factoring out that 2. Yeah, so if you're ever worried that you factored it in incorrectly, I always sometimes just really quick in my mind check by distributing it back out to see if I get back to the original 2x minus pi. It's a good thing to check that, just because it's easy to accidentally get it wrong. Yeah, good. So this one here was 3 sine 2x minus pi plus 1, I think. The period we calculated to be pi, and the phase shift was right pi over 2. So just like before, we want to go to where the old period, so 2 pi used to be the period of sine. So here now the period is going to be pi, so we'll replace the old coordinate with pi, and then scale it from there. So that's pi over 2, and pi over, we want a 4 there, so pi over 2, pi over 4, and then count by pi over 4s to get 3 pi over 4 right there. Okay, so once you've done the scale, that's the first thing. The second thing is the vertical shift and putting in the center line. So the vertical shift is up 1, and the center line is there at 1. The phase shift tells me that I need to shift to the right by pi over 2. So we want to put the new center point there at pi over 2 on the center line. And then we just want to graph the graph of sine just like normal. So we'll put a point right on the center point. Sine always has a point on the center point. And then we'll go 1 to the right up to a peak. If there's no reflection, sine always goes to the peak first, and then it comes back down. And we'll put the rest of the points in going the other direction, and we'll connect them. Yeah, so there's sine. Yeah, so that's, uh-oh, I made a mistake. Yeah, I didn't do the times 3, so this should be 3 times as big. It's not going to let me stretch it, so we'll get rid of it. Yeah, there we go. And yeah, so these should be 3 higher. So let's put these up a little bit higher. Whoops, I'm gonna have to get rid of these two. So the amplitude, what I forgot was the amplitude is 3. So these points, instead of going up 1, should be going up 3 and down 3. Okay, that looks better. Good. Okay. Yeah, I think that looks good. So let's go back to number, what are we up to? Number 7 now. We're going to do the odds. So number 7 is 2 secant. So secant has no amplitude, so we'll say none. And its period is 2 pi over 2 again, so yeah, that's pi. And let's factor out a 2 here. So this is going to be x minus pi over 4. Good. Pi over 4. If you're unsure of that, you can just distribute the 2 back through and check. But so that means a phase shift to the right by pi over 4, and we are shifting up by 3. Okay. So let's go 2 pages forward, and we'll plot this graph. Secant of 2x minus pi over 2 plus 3. I think this might be one of the hardest ones we've graphed to this point. So oh, I don't remember. Is it a 2 in front? I think. Yeah. Thanks. There we go. Okay. Period we calculated to be pi, so we'll put that here. And then the phase shift, yeah, right, pi over 4. Okay. And let's put the scale down first. That should always be the first thing that you do. So we use pi out at the end because we're replacing 2 pi with pi, replace the old period with the new period. The phase shift is to the right by pi over 4, and we want to go up 3. So our new center line should be right here, up 3, and we're going to go to the right pi over 4, so that's where the center point should be. Okay, that looks good. And we want to do a dotted line cosine. Yeah, cosine. Okay, so yeah, 2 high. 2 cosine, so it should be double. So the first point for cosine starts out at the peak, so we want to be 2 above the center point, and it's going to come down, yep, just like that, and come down on either side. Okay, so there's our dotted line cosine graph. Secant has a vertical asymptote on either side, either hash mark of our center point. So we can go ahead and put those vertical asymptotes in. Another way that you could think of it is wherever the dotted line cosine graph crosses the center line, that's where you're going to have vertical asymptotes. But once you get 1, you can just get the spacing down as 2. Okay, and let's go ahead and put points at the peak and at the valleys. All the peaks go up and all the valleys go down. The irony behind this graph is it looks a lot like cosecant when it's really just secant. It looks like cosecant in reference to the original coordinate plane, but it's really just a shift of secant. Yeah, just a shift. All right, good. Okay, let's go back and try this one, number 9. This one, unfortunately, I think it doesn't fall on the hash marks nicely. So since it's sine, we do get an amplitude here of 1. And the coefficient that we want to pull out here is going to be Well, we want to pull out a 1/2, so that you just have an x minus a value. So we're pulling out a factor of 1/2. That pi over 4 becomes a pi over 2. Again, if you're unsure of that, distribute the 1/2 just to check. 1/2 of pi over 2 is pi over 4. So that checks out. So when calculating the period here, we want 2 pi over 1/2. That's the coefficient of x. And that's going to give me 4 pi. So it doubles my period there. This is a horizontal stretch. And let's see, the phase shift is to the right by pi over 2. Good. And we do have a vertical shift up 2. Okay. That looks good. So let's go to number 9, and let's see if I can remember what the function was. X over 2 minus pi over 4 plus 2. Thank you. Okay, that looks good. The new period we calculated to be 4 pi, and the phase shift is to the right pi over 2. So we want to replace 2 pi, the old coordinate right there, with a 4 pi, cut that in half, and cut that in half to get our new scale. So there's our new scale. Notice we're shifting to the right by pi over 2, which is unfortunate. So we're going to have to come through here, split each one of these hash marks in half. That way we have a scale of accuracy pi by 2, half of pi. So that will give us our scale. We'll put in the center line at 2. And we want to shift to the right pi over 2. So that's going to be right there. So all of our points here aren't going to fall on the big hash marks, but the middle points. Sine starts out on the center point. And the amplitude is 1 here, so we want to go in between the next 2 hash marks, right in the middle, and put points at the peak and coming down. And all of our points should be right in the middle, just like this. There we go. That looks good. So it's shifted slightly to the right. There is a stretch, horizontal stretch, and a shift up is all that happened there. Yeah, looks good to me. Okay, one last one. And then we are free to the weekend. Here we go. So the last one is a graph of cotangent. We haven't seen tangent or cotangent yet today. So this one's cotangent, and cotangent has no amplitude, so none. I don't care that there's a number out in front. It goes infinitely far away from the center line, so there's no amplitude. The period formula, remember, is different for tangent and cotangent. We want pi over b. Pi over b, and b here, if you factor out the 1/2, is like the previous problem. We're going to get x minus pi when you factor out the 1/2. So the 1/2 is what calculates the period, so we get pi over 1/2 or 2 pi. So 2 pi is the period, and we do have a shift to the right by pi. And it is shifting up by 1. Say that again, or shifting to the right by pi because tangent's period is pi. Well, tangent's period used to be pi and cotangent, but since the new period is pi, so it will appear that there is kind of a shift. Yeah, Sam.
Whatever that x is related to, and then multiply it by that way, because like x divided by 2, so it's going to be doubling.
Yes, yeah.
X times 2,
yes, yeah, so it's opposite of what this number is. Like, I would think half means that you have a smaller period, but it actually doubles your period, makes it twice as big. So yeah, so 2, this would be a compression, this would be a stretch. So,
With 11, you look at it, it's pi over 2, the x is also divided by 2, so you're multiplying the right side by 2 to get pi. And then you look at number 9,
yeah.
dividing it by 2, multiplying by pi over 4 by 2 to get
Pi over 2. Yeah, I mean, yeah, this is like an unscaled phase shift. And so when you factor out that half, yeah, it's like a scaled phase shift. Yeah, good. Okay, so let's go plot number 11. See if I can remember what the equation was. I think it's -3 cotangent x over 2 minus pi by 4 or 2, and then plus. Was there a plus? +1. Okay. Phase. Let's see. The period is, we calculated to be 2 pi. And the phase shift, we calculated it to be right pi. So cotangent and tangent's period is normally pi, which goes right here. So what we want to do is replace that with the new period, which is 2 pi. So we're going to put 2 pi right where tangent's old period was. We're going to cut that in half to get the scale, and the scale is going by pi. So 1, 2, 3 pi. And 4 pi. Let's go ahead and put the center line in. It's shifted up 1. And the phase shift is to the right by pi, so that's right here. Cotangent and tangent, or cotangent and cosecant, have vertical asymptotes right through the center point. Right through the center point, and then it alternates every other hash mark from there. So you can go ahead and put those down just like that. So the way that I remember cotangent is it's right through the center point. Secant and tangent are on either side of the center point. Okay, that looks good. Let's go ahead and put points right in between the vertical asymptotes. And now tangent looks like this. And cotangent goes down on the right and up on the left. So which one do we want here? Well, yeah, we want the tangent look because we have a reflection. That -3 is going to flip our graph upside down. So if I put hash marks halfway in between here, between 0 and pi at pi over 2, we can actually indicate this stretch by 3 by going up above 3 of the center line and down 3 below the center line, and it should look something like tangent, just like that, just stretched. So you just want to get some type of stretched look to your graph. I'm not going to be super picky when grading, but it should look like stretched. A good way to show the stretch is putting those points 3 above the center line there. Now, what's funny about this graph is it looks a lot like tangent. It looks a lot like tangent. In fact, we can even write the equation for it. What would the equation be? Let's see if you can help me write it here. So tangent, what should the coefficient be of tangent? 3. Are you sure I don't want a -3? Yeah, so we want just a positive coefficient because it already is in the proper shape here. So we want a +3, and we want the same compression, or same stretch. But there's really no phase shift. So there's no phase shift here because tangent's asymptotes are on either side of the origin, but there is a shift up by 1. And so this graph, if you were to graph this graph, and our original graph of cotangent, there would be no difference between them on a graphing utility like a calculator. They're the exact same graph. The only really difference that we would plot is that the red X would be right here. for tangent. It just, because this one would have no phase shift. But yeah, so these two graphs are identical. I like this one better, the one down here. That one's better. Anyway, okay, so your homework is to finish worksheet 6, so the even ones that we didn't do, and worksheet 7. There's a lot on worksheet 7 as well. It's quite a bit of work there, so try to get a good jump start on it. You will probably want to get out another sheet of paper to graph those. I didn't put graphs into your notes packet, so you're going to want to put some, maybe get out some notebook paper for that as well. Next class, I think what we're going to do next time is more practice with this on worksheet 8. So that's going to be, you're going to see me again on Tuesday. So we'll do more practice with that. I think what we're also going to do is a matching activity in class where I give you some cards and we'll match them. But yeah, the test won't be until, for you guys, until I think the 18th. Monday the 18th is where I'm going to give it. Okay. All right, well, I think that's it. Let me turn this video off.